Okay, here's the question. For each pair of points, A and B, find delta x and delta y in going from A to B, find the slope of the line joining A and B, find the equation of the line joining A and B in the form y equals mx plus b, and then find the distance from A to B. Now we have 6 different pairs of points, and I'll do each one in a different video. I'm having some memory issues here with my video software. But before we get into these 6 pairs of points, let's go through the equations for each of these expressions. So if we have 2 points, A and B, and A consists of coordinates x1 and y1, and B consists of coordinates x2 and y2, then delta x, going from A to B, is going to equal x2 minus x1. Similarly, delta y will equal y2 minus y1 if we're going from point A to point B. The slope of this line, of the line that joins these 2 points, is equal to delta y over delta x. And so this is equal to y2 minus y1 over x2 minus x1. Now this also equals, just so you know, we can flip the subtraction on both sides and we still get the same number. So this is also equal to y1 minus y2 over x1 minus x2. Now the y-intercept is a similar calculation. Now, not all lines cross the y-axis. Specifically, vertical lines do not cross the y-axis, but for every other line, there is another point, C, which consists of the value of the y-intercept, b, and an x-coordinate of 0. So if we think of the line like so, and if we, here's the coordinate plane, and if we think of a line, that point right there has coordinates 0 and b, where b is the y-intercept. And so if we want to get the function of our line in this form, y equals mx plus b, well, we already have m, we have the slope, and b is something that we can calculate. The slope of the line can be calculated with any 2 points. So up here we calculated the slope with point A and point B. Now what happens if I calculate the slope using point B and point C? Well, the slope m is equal to b and c. So y2 minus b over x2 minus 0. And this simplifies to y2 minus b over x2. Now if we solve for b, then what we get is b is equal to, see if I multiply through by x2 and I flip things over, this should give us b is equal to y2 minus m x2. And then finally, the distance calculation. The distance is equal to the square root of delta x squared plus delta y squared. Simple as that. And this expands out to x2 minus x1 squared plus y2 minus y1 squared. So in this video, I'll do point pair A, so question A. So in the case of question A here, we've got point A is 2, 0, and point B is 4, 3. So delta x is equal to x2 minus x1. So this is 4 minus 2, which is 2. Delta y is equal to y2 minus y1, which is 3 minus 0, which is 3. The slope, m, is equal to delta y over delta x, which is 3/2. So if you heard that, that was my dog, sorry. The y-intercept, and I'll calculate the y-intercept using point B. The y-intercept is equal to y2 minus the slope times x2, which in this case is 3 minus 3/2 times 4, and this is equal to 3 minus 6, which is equal to -3, which means that the equation for our line is y equals mx plus b, which is equal to 3/2 x minus 3. And then finally, the distance between these 2 points is going to be equal to delta x, the square root of delta x squared plus delta y squared. So this is just, so delta x is just equal to 2, and delta y is equal to 3. So this is 4 plus 9 square root. So this is equal to the square root of 13. And for accuracy, I would just leave it like that. I wouldn't turn that into a decimal. I would just leave it as the square root of 13. So you can tune in for the other 5 pairs of points. I'll put those up here in a few minutes.